What's the one thing that tech enthusiasts and container orchestration fans can't stop talking about? Kubernetes, of course. Picture this. Kubernetes is like your favorite puzzle game, only with more moving parts and a dash of tech jargon. Each piece, or rather node, plays its part in this intricate game of container orchestration. And when they all come together, they form the Kubernetes cluster architecture, a thing of beauty and efficiency. So, are you ready to dive deep into the world of Kubernetes and unravel its mysteries? Hold on to your seats because it's going to be a fun ride. Before we jump into the depths of Kubernetes cluster architecture, it's essential to understand what Kubernetes is. Picture this. You're a maestro, and you're tasked with conducting a vast orchestra made up of various instruments, each with their own specific role and timing. Now imagine these instruments as containers in the world of technology, and you, the maestro, as Kubernetes. Kubernetes, often abbreviated as K8s, is an open-source platform designed to automate deploying, scaling, and managing containerized applications. Containers, in a nutshell, are lightweight, standalone executable packages that include everything needed to run a piece of software, including the code, a runtime, libraries, environment variables, and config files. So, why is Kubernetes so significant? Well, in our fast-paced digital world, businesses need to rapidly deploy and scale applications to meet demand. However, managing these containers manually can be a daunting task, especially when working with large-scale systems. This is where Kubernetes steps in like a maestro, taking the baton and ensuring each container plays its part at the right time, in the right place. Whether it's rolling out a new feature, scaling up during peak times, or rolling back to a previous version, Kubernetes handles it all seamlessly. It removes much of the manual processes involved in deploying and scaling containerized applications, allowing teams to be more efficient and applications to be more reliable and robust. So in simple terms, Kubernetes is the conductor of the container orchestra, ensuring every container plays its part perfectly. Now, let's get our hands dirty and dissect this beast called Kubernetes cluster architecture. Kubernetes is a complex creature, but at its heart, it's composed of some pretty straightforward components. Let's start with nodes. Nodes are the worker bees of the Kubernetes world. They're the machines, physical or virtual, that run your applications. Each node is a self-contained unit capable of running pods, which are the smallest deployable units within the Kubernetes ecosystem. Now, onto pods. Picture a pod as a cozy little house for your application, complete with its own IP address and storage. Each pod can contain one or more containers, and these containers within a pod share the same network namespace. This means they can communicate with each other using localhost and have access to the same volumes for storage. That brings us to the control plane. If nodes are the worker bees, the control plane is the queen bee. It's the brain of the operation, making all the key decisions, like scheduling pods, responding to cluster events, and implementing policies. The control plane consists of several key components, including the Kube API server, the scheduler, and the controller manager. Finally, we have services. Services are like the phone book of the Kubernetes world. They provide a consistent way to route network traffic to pods. So, even if pods are coming and going, services ensure that the network traffic keeps flowing. Now let's talk about the Kubernetes API. This is the lingua franca of Kubernetes. It's how all these components communicate and coordinate. Whether you're a human operator using Kubectl or an application talking directly to the cluster, the Kubernetes API is the communication channel you're using. So these are the building blocks of Kubernetes cluster architecture. But how do they interact with each other? Let's find out. Just like in a real orchestra, every player in Kubernetes needs to interact harmoniously with others to create a beautiful symphony. Now, let's delve deeper into how these players or components of the Kubernetes cluster architecture interact with each other. Imagine the Kubernetes cluster as a bustling city. The control plane acts like the city's administration, making sure everything runs smoothly. It interacts with nodes, which are like the city's neighborhoods, each housing several pods, our city's inhabitants. The control plane is the maestro of our Kubernetes orchestra. It has several key players like the API server, which is the communication hub. It's like the city's post office, handling requests and responses between different components. Then, there's the scheduler, akin to a city planner, deciding where new pods should live within the nodes based on resource availability and other constraints. The controller manager is the city's maintenance crew, ensuring the actual state matches the desired state. If a pod goes down, it's the controller manager's job to get it back up and running, just like the city crew would fix a broken street light. On the other side, we have nodes, the neighborhoods of our city. Each node has a Kubernetes, like a local council, communicating with the city administration, control plane, and ensuring the pods in its neighborhood are running smoothly. Pods are the smallest deployable units and interact with each other via networking. They are like the city's residents, working together to keep the city thriving. In the middle of all this hustle and bustle, there's the etc read, a consistent and highly available key value store, acting like the city's library, storing all the cluster data. These interactions within the Kubernetes cluster ensure everything runs harmoniously. Each component plays its part, communicating, coordinating, and collaborating to keep our Kubernetes city, or rather our Kubernetes orchestra, playing its symphony. So that's how the Kubernetes orchestra plays its symphony. But what happens when a new player joins or an old one leaves? Stay tuned to find out more about the dynamic nature of Kubernetes cluster architecture. In the world of Kubernetes, change is the only constant. So how does Kubernetes handle scaling and updating? Let's dive in. Scaling in the Kubernetes context is the process of adjusting the number of replicas or instances of an application to meet its current demand. It's like a concert where the conductor, Kubernetes, summons more violinists or drummers based on the rhythm of the music, that is, the load on the system. In Kubernetes, this is achieved using a feature called autoscaling. There are two types, horizontal and vertical. Horizontal pod autoscaling, or HPA, adjusts the number of pod replicas in a replication controller or deployment. It's like adding more drummers to keep up with the rhythm. On the other hand, vertical pod autoscaling, or VPA, adjusts the CPU and memory reservations for the pods, like giving a drummer a bigger drum or more drumsticks. Now, what about updates? We all know the tech world is ever evolving, and so are applications. Kubernetes ensures zero downtime during updates using a technique called rolling updates. Imagine our orchestra again. While the concert is ongoing, Kubernetes seamlessly swaps out the violinist playing an old tune with another one ready to play a new tune, all without stopping the music. That's your rolling update. Rolling updates happen at the deployment level. Kubernetes gradually replaces instances of the old version of the application with the new version. If anything goes wrong, Kubernetes can roll back to the previous state. This is possible through its declarative model, where you declare the desired state of your system, and Kubernetes does the heavy lifting to achieve that state. Moreover, Kubernetes also provides readiness and liveness probes. These are like the conductor's keen ears, constantly checking if the players are ready to play and are playing correctly. If not, Kubernetes ensures they are replaced or healed, maintaining high availability. So, Kubernetes not only conducts the orchestra but also seamlessly manages the entry and exit of players. Isn't that fascinating? We've covered a lot of ground today, folks. Let's take a moment to summarize what we've learned about Kubernetes cluster architecture. Diving headfirst into the world of Kubernetes, we started off by understanding what exactly it is. Kubernetes, a Greek word for helmsman or pilot, is indeed the pilot of our containerized applications. It's an open-source platform designed to automate deploying, scaling, and managing containerized applications. We then broke down the Kubernetes cluster architecture into its core components, the master node and the worker nodes. The master node, which is like the brain of the operation, is responsible for maintaining the desired state of the cluster. It communicates with worker nodes, where our applications actually run, through the Kubernetes API. Next, we delved into the interactions within the Kubernetes cluster architecture. We learned about the roles of the various components in the master node, like the API server, the controller manager, scheduler, and etc. We also explored how worker nodes run pods, which are the smallest deployable units in a Kubernetes cluster, and how services expose these pods to the network. In the scaling and updating section, we discovered how Kubernetes makes it easy to scale our applications to meet demand. We learned about replication controllers and replica sets and how they ensure the correct number of pods are running. We also discussed rolling updates, allowing us to update our applications without downtime. This journey through Kubernetes cluster architecture has been like navigating a maze. Yet, the beauty of Kubernetes is that it makes managing complex containerized applications feel like a walk in the park. And with that, our deep dive into Kubernetes cluster architecture comes to an end. Remember, in the world of Kubernetes, there's always more to learn. So keep exploring, keep learning, and stay curious.